Uh, Thank you. So yeah, my name is Jared Denman. Put this presentation together on the proposed VAC forecaster workflow for QVA issuance. We did have the help from all the other VACs yesterday going through this process to kind of come up with a kind of high level goal for our workflows for all of our forecasting teams. So I'm going to go through that today. So just quickly going through kind of the current workflow that we have. So some of the questions that have been asked today may have a couple of answers coming out through this presentation as well. So when the information arrives to us, we get for new volcanic activity, could be through the VONA or a report from the Ground Observatory or SVO, satellite imagery, pilot reports, etc. So I've got a number of different information sources up here on the screen as well. So lots of different information that we get. So the VAC forecaster will assess that information, confirm something has sufficient evidence to be issued as a volcanic ash advisory. They will then issue the first volcanic ash advisory within 20 minutes of the credible evidence that they actually have. Then they'll go on and that VAA, so volcanic ash advisory, will be a basic product with an observation and just a bit of information in there. They'll then continue to assess the situation, so determining the height or rechecking the height, the eruption start and end times, so multiple different sources, movement directions to try and get a handle on how high is the ash. So the height of the ash is a very key parameter in terms of getting your dispersion modeling outputs correct. So and start and end times as well, plus the uncertainties from your NWP data. So you then run your dispersion model and prepare a forecast. So you usually get the second volcanic ash advisory issued within 55 minutes after the first volcanic ash advisory, sometimes quicker depending on the situation. And then the forecaster will then continue to analyze and update the situation until the event has ended. So just as a flow chart, what I just spoke through then on the last page is actually here for general monitoring, the alert or the information sources that come into the VAC, issuing the initial VAA. So the product's issuance here is actually in green to highlight where in the chain a product would be issued. These next two steps are kind of interchangeable in terms of analyze information and trigger or run a dispersion model, then issue the second or the first full volcanic ash advisory and graphic. You'll then exit the initial stages and then go on to kind of the routine process for issuing the volcanic ash advisory. So potentially triggering a new dispersion model run or comparing and looking at your output from your previous run, and then continuing to analyze information, making sure you've got everything correct. You get to the point in the chain, it's like the forecaster would look at it and go, well, is the ash still discernible on satellite imagery? Or do you have credible information stating that there's still ash in the atmosphere? So if there's yes, you'd go through and you'd issue the volcanic ash advisory and graphic, which you can see down the bottom here in the chart as another green box as the product being issued. And you continue going through that loop until the event has ended. So you get to the checking discernible ash or information stating ash in the atmosphere. If there's not, then you would end it. So that's the current workflow that the VAC forecaster in all of the VACs will go through. Minor tweaks, this is just high level, but there could be some more detail at different VACs in this chart here. So as we move to QVA, it will be the initial operating capability. capability. Will be issued for significant volcanic ash. So we have a significant ash definition that will be in Annex 3, which is there on the page as well, which gives a guidance on what that will be. So it won't be for every eruption, but it'll be something that poses widespread impact to aviation or aircraft operations and air navigation. Persistence in the proximity of aerodromes and international airways. So there's the definition. But as a group of 9 VACs, we're looking at a consistent way of applying this between all of our forecasters. So making sure we have enough guidance for the forecasting teams to actually apply this consistently, because there's over 100 VAC forecasters combined within each of the areas, each of the VACs. So we need to make sure they're all doing it in a similar way. It could take a little time to ascertain the accurate information for the eruption parameters. and potentially then to determine if the eruption is significant. So just making sure our teams have that information to provide a consistent service. So that's what we're looking for here, is something that's consistent from all of the VACs. So things that we have to consider is looking at, there's been discussed already about eruption source parameters and whether the uncertainties are coming from those. So height, start time, end time, how much mass is ejected in the eruption versus uncertainties in NWP data. So, trying to accommodate for both of those. So making sure that we've got an accurate representation of those. Large events in clear conditions could be providing your best outputs because we can actually get an accurate read on that information. So here we've got a ground report for this case, which was a Mount Sinabung eruption in Indonesia in 2018, I think it was, 55,000 feet, but we had a ground report for it. We had clear webcam imagery. We also actually, because it was clear imagery, we could actually really assess the information that we were seeing on satellite imagery. So the height of the eruption, even seeing a shadow of the plume. And then as the imagery started, so you can see in the images there, it started at 02 UTC. And then by 03, we actually had a good handle on which direction parts of the ash were moving. So when you look at something like that, you'd be like able to compare your dispersion outputs and then actually look at it and go, well, the output models that we have are matching that quite well. So potentially it's good quality data there that we could actually provide to the operators. We may also get satellite retrievals as well, which can help with the input parameterization that you'd apply to these events. So those are down on the bottom on the left. Other things to consider is we still have similar challenges to forecast accuracy. So limited information, partial information, where it could be covered in cloud. So the animation there is for a Cinnabung event, again, a couple of months after the first one, where it was covered in cloud and we had limited information on the satellite imagery. We had a ground report that, in this case, provided some information, but to help us improve the certainty in this information, we need additional information sources coming into us. So we would need a lot more information and support from the SVOs through VONAs, webcams, pilot reports, extremely useful additional information to help us reassess key parameters such as height. And then the use of probabilistic information would accommodate the uncertainties in some of this data as well. So using that in cases where there's a little bit more uncertainty. But dispersion models are always improving. And with the 9 VACs, each VAC has a research area discussing case studies. And we are now actually starting to engage a lot more on that level where we compare case studies and work together, publish research, but also share it. So we're looking, there's a lot more work going on in this space. So a lot more improvements being made to dispersion modeling. So the forecaster would be in control of quality, will be in charge of quality control of the outgoing data. So quality control could be rerunning the eruption changes for poor parameterization, or eruption has changed, it's pulsed and there's a slightly higher level as well. Reviewing that data in the form of the volcanic ash advisory graphic and the QVA gridded data and IWXM files, then accepting or discarding and potentially rerunning again if necessary. The alignment of the VAG with the QVA IWXM file and gridded data. So the VAA polygon will contain the 0.2 milligram per meter cubed QVA IWXM contour. So your VAA still will cover everything that's in that IWXM file. But then also they'll be able to provide some support to aviation customers. If there's questions on what the data is representing or maybe trying to understand it, the forecasters will be able to support that. So how would that change our workflow and what we would expect the forecasters to be working on? So the first part of it on the left is still the initial steps, but you can see now it's grown for the next part. So the rotation through or the routine step updates. So we'd look at, is it significant? Yes or no? How accurate is the data that we may have collected for the input? for the systems. If no, you can actually still then go and you'd be doing your dispersion model output, analyzing the information, and then issuing your volcanic ash advisory and graphic. So that could be in cases maybe it's not significant, you'd still be doing that loop. But then the forecaster, if it's determined that it's significant, they would actually go and look at the dispersion model output. We would hope to automate some of the IWXM contours from the gridded data set that we have to help the forecasters workflow. Looking at automating the VAA polygon based on the QVA IWXM file. So again, just making sure things are consistent with the data so that there's not a lot, no differences between the information coming out. The forecaster would then be able to go and have a look at the VAA polygon. Is it covered correctly by the 7 points that they've used in their advisory, or is it better defined by 6? So just, maybe viewing that and checking that. The quality control step, and then there's an out there maybe that if it's really not matching and they've got to issue the volcanic ash advisory, because the volcanic ash advisory and the QVA data sets will come out at the same update intervals of every 6 hours. So, if it's not suitable, then it could potentially just be you issue your volcanic ash advisory and graphic. If it's all good and passes the quality control, you would issue the volcanic ash advisory, graphic, and QVA datasets. So and you'd keep going through that loop until, again, there's no ash discernible on satellite imagery or information states that there's no ash in the atmosphere. So for the aviation perspective, what would airlines expect to see in terms of products coming out? So you'd have your first volcanic ash advisory that would be provided. So your volcanic ash advisory and graphic. You'd get your follow-up volcanic ash advisory with a full forecast. So after that one's issued, the products usually say updated within at least 6 hours. So there'll be a couple of hours there that the VACs can determine significant, make sure the data is reasonable before issuing that. So it may be that the VAC goes through an update cycle of an hour after the follow-up volcanic ash advisory. They may want to issue and update the and start issuing QVA. So they'll do an updated volcanic ash advisory graphic and QVA. So giving a little bit of leeway there, but more likely within a couple of hours or an hour after, maybe earlier if there's really good conditions. If it's significant, you'd then expect to see the volcanic ash advisory and graphic being issued with potentially a remark saying that QVA is also there. You'd then have the QVA IWXM file, gridded data sets, deterministic and probabilistic, available in the API. And then just a reminder again that the volcanic ash polygon will enclose the 0.2 milligram per meter cubed, which is the lowest concentration, and that the volcanic ash sigmet is still suggested to align with the volcanic ash advisory and graphic, which is in Annex 3. As Paula said before, it's not changing. It's suggested that it should be based on, which is down the bottom. It's the wording is still there and will be there in the next update to Annex. If it's not significant, then you'll be getting the volcanic ash advisory and graphic, and then the volcanic ash sigmet, which will still be aligning with the volcanic ash advisory and graphic. Thank you. I'll leave it there.